And so I want to touch on that element of science which is about the diagnostic element. But importantly, if we're thinking about policy and investment, what are the futures and how are we going to get to those futures? And so I'll just touch on those over the coming slides. So when we talk about science to policy, what do we mean? What are the elements? So firstly, I would say it's that evidence base. So we don't base policy on saying, well, I think that would be good. It's actually, what is the evidence? And let's talk about evidence because it's quite a broad number of strategies. So the first thing I would say is the diagnostic. What is the scale of the problem? What is the magnitude of the problem? Where is that problem? And we can look at that, we can generate data, we can show maps, we can analyze that and say, these are the hotspots, these are the targets, this is what we need to hit. And that might be social, that might be economic, or it might be biophysical. So we've got a feeling of where we are now. So we can think about, we know where we are now, roughly in terms of population. We know roughly where we are in terms of climate. But where are we going to be in 2030, 2050? And how are we going to meet those needs? So then we need to develop those scenarios. And those scenarios need to hit those targets and have realistic pathways of how we're going to get from here to 2030 to 2050. And then the role of science is to work with stakeholders, with policymakers, with investors to say, well, what are the range of policy options? What do they look like? Who do they impact? Because you don't want to put in a policy that will adversely impact another part. And when you do, if you do that analysis and take that route, you will then be able to identify synergies and indeed the trade-offs. So it was interesting watching Jessica, one of